There is a specific kind of silence that falls over a job site when $500,000 worth of modern equipment is officially declared dead. It is the sound of expensive experts realizing their math doesn't work in the mud. On the afternoon of Thursday, the 14th of April, 1994, at the edge of a flooded drainage canal in southern Illinois, a 38-year-old site foreman named Mark Davies stood in that silence. He was watching a $400,000 piece of modern engineering slowly disappear into the earth. The machine was a nearly brand new 40-ton hydraulic excavator, currently buried up to the bottom of its cab in deep, merciless black clay. Standing on the solid gravel road 50 yards away was a crew of 6 men from a commercial heavy lift recovery company out of Chicago. They had been on the site for 10 straight hours. They had brought 2 massive twin-axle heavy wreckers equipped with 50-ton hydraulic winches, and they had just officially given up. The lead recovery engineer, a man whose expertise, billed out at $250 an hour, stood by his pristine truck and told Mark the excavator was a total loss for the season. He explained that the immense static suction created by 40 tons of steel buried in wet clay effectively doubled the machine's dead weight. The hydraulic winches on the modern wreckers had simply spun their heavy rubber tires on the gravel, completely unable to find enough traction to overcome the drag. The engineer declared that the only physical way to save the excavator was to wait until late July for the ground to bake into concrete, dig the tracks out by hand, and drag it out in pieces. He wasn't guessing. He was reading the absolute calculated limits of his modern equipment. As the recovery crew began angrily packing up their heavy steel cables, an old man in a faded denim jacket stepped out of a rusted Ford pickup that had pulled up unnoticed on the county road. His name was Arthur Vance. He was 70 years old. He looked at the sunken excavator, looked at the frustrated Chicago engineer, and quietly offered to pull the machine out by dinner time. The recovery crew didn't just dismiss him. They laughed out loud. Arthur didn't have a 50-ton hydraulic winch. He only had a 50-year-old piece of rusted iron sitting on a heavy equipment trailer down the road. But their laughter relied on a fundamental assumption about how force is applied to the earth. The modern crew was reasoning from raw horsepower. Arthur was reasoning from ground pressure. The commercial recovery engineer wasn't a fool, and his equipment wasn't cheap. He had brought 2 state-of-the-art heavy wreckers. Combined, those trucks possessed over 800 horsepower and immense hydraulic pulling capacity. But pulling a 40-ton excavator out of a wet clay trench is not a matter of horsepower, it is a matter of traction. The moment the wreckers applied tension to the cables, the sheer drag of the clay essentially turned the trapped excavator into an 80-ton anchor. The wreckers, sitting on rubber tires on a loose gravel road, simply did not have enough contact area with the earth to transfer their immense engine power into a forward pull. Their tires lost their grip, spun wildly, and burned rubber against the crushed stone. No matter how much hydraulic force the winches generated, the trucks themselves couldn't hold their ground. The suction was too great, and the traction was too low. The idea that a 71-year-old local farmer was going to achieve with a single antique machine what 2 purpose-built $500,000 recovery trucks could not do was, to the modern mind, mathematically absurd. But the machine Arthur had chained to his trailer was built for a world that was tearing itself apart. In the early 1940s, during the height of the Second World War, the American military needed a machine that could drag massive artillery pieces through the ruined, bottomless mud of European battlefields and carve airstrips out of impenetrable Pacific jungles. They didn't need speed. They didn't need electronic sensors. They needed pure, relentless, unyielding, mechanical traction. The Caterpillar company answered with the D7 crawler. It was an absolute monster of forged iron and steel. It was powered by a massive naturally aspirated 4-cylinder diesel engine that produced a meager 80 horsepower at the drawbar. To the modern engineer staring at his screaming 400 horsepower wreckers, 80 horsepower was laughable. It was the output of an economy car. But horsepower is simply a measure of how fast work can be done. Torque is a measure of how much work can actually get done. The D7 didn't use its engine to spin tires quickly. It used its engine to turn massive internal reduction gears, multiplying that low-end torque to an incredible degree. More importantly, the D7 didn't use rubber tires. It used a continuous track of heavy steel plates, creating an immense footprint that distributed its 31,000-pound weight evenly across the earth. While the modern rubber-tired truck sat on the surface of the gravel and spun, the 1,945 Caterpillar D7 was designed to grip the dirt like a heavy iron fist. Arthur Vance hadn't brought a fast machine to the trench. He had brought a machine that simply refused to let go. The recovery engineer kept laughing, but the site foreman, Mark Davies, was out of options. His excavator was sinking an inch an hour into the slurry. By tomorrow morning, it would be swallowed whole. He told Arthur to back his trailer up. Arthur didn't boast, and he didn't promise a miracle. He simply backed up his pickup, unchained the 1,945 crawler, and started the massive pony motor with a sharp, mechanical crack that echoed across the flooded fields. A moment later, the main diesel engine roared to life, blowing a thick column of dark soot into the gray sky. Arthur didn't drive the D7 to the edge of the trench. Instead, he drove it 50 yards in the opposite direction, stopping the crawler near a stand of massive, mature oak trees. The modern crew watched in utter confusion as the old man climbed down from the steel seat. Arthur wasn't planning on dragging the excavator out with a straight pull. He knew that even the 31,000-pound crawler couldn't defeat the suction of 40 tons of wet clay in a direct tug-of-war. Instead, Arthur walked to the back of his pickup and hauled out two incredibly heavy rusted iron pulleys, a traditional block and tackle system. He chained one massive pulley to the base of the largest oak tree. He walked down to the trench and handed the end of a thick steel cable to Mark, instructing him to hook it directly to the undercarriage of the buried excavator. Arthur was rigging a mechanical advantage by running the cable from the excavator back to the tree pulley, through a second pulley on the D7's drawbar, and finally anchoring it back to the tree. He was using basic physics to multiply the pulling force of his 80-horsepower machine by a factor of 3. The modern wreckers had tried to fight the mud with screaming engines and raw hydraulic pressure. Arthur was going to fight it with cold geometry. Climbing back into the heavy steel seat of the D7, Arthur eased the main clutch lever forward. The Caterpillar didn't lurch, it didn't scream, and it certainly didn't spin its tracks. It simply leaned its dead weight into the heavy steel cables. The modern recovery crew watched silently, fully expecting the old tractor to stall out or its tracks to break traction and spin uselessly on the gravel. But the D7's continuous steel tracks distributed its 31,000 pounds over a massive surface area, resulting in a ground pressure of barely 8 pounds per square inch, less ground pressure than a grown man walking. It didn't break the surface tension of the gravel. It locked into it like a bank vault. Through the rusted block and tackle system, the D7's meager 80 horsepower was steadily multiplying its drawbar pull. For a long, agonizing minute, nothing seemed to happen. The cables vibrated with terrifying tension, shedding flakes of rust. And then, from the bottom of the flooded trench, a terrible, wet, sucking sound echoed across the fields. It was the sound of a vacuum breaking. The black clay, which had completely defeated raw hydraulic speed, was slowly yielding to relentless, multiplied torque. The massive, buried excavator shuddered, and then inexorably began to move. Inch by agonizing inch, the 40-ton excavator began to drag forward. It wasn't fast. The old D7 crawled at a pace of barely 1 mile per hour, its diesel engine throbbing with a deafening rhythmic percussion that shook the ground right through the soles of the men's boots. But it never stopped. The massive iron pulleys groaned under the strain, perfectly translating slow forward motion into irresistible lifting force. After 20 grueling minutes, the front tracks of the modern excavator broke the surface of the mud and bit hard into the solid gravel bank. The suction was dead. The $400,000 machine was dragged completely out of the trench and onto safe, dry ground. Arthur Vance pulled the clutch lever back, idling the roaring D7 down to a quiet, steady rumble. The recovery engineer walked over from his pristine truck, staring intently at the rusted iron pulleys and the meticulous, unyielding geometry of the cables. He didn't offer a dramatic confession of his own arrogance. He was a professional who respected the hard laws of physics, and he had just watched physics behave perfectly in the calloused hands of an old farmer. He took off his hard hat, looked at the old man climbing down from the steel seat, and quietly admitted that the math was flawless. The heavy lift experts had brought speed and raw pressure to a problem that fundamentally required patience and footprint. Arthur Vance didn't gloat. He simply nodded at the engineer, walked back to the trench, and began the heavy work of unhooking his chains from the oak tree. The 1945 Caterpillar D7 was not a universally superior machine. It had no enclosed cab, no climate control, no joysticks, and no precise hydraulic articulation. It was deafeningly loud, incredibly slow, and operating it for 10 straight hours on rough ground would physically beat a man's spine to a pulp. The modern yellow excavator sitting dripping on the gravel could dig a perfectly level, laser-guided trench in a fraction of the time it would take the old crawler to just clear the topsoil. For 99% of modern construction tasks, the antique tractor was completely and utterly obsolete. The engineers were not wrong to rely on their modern fleet, but Arthur hadn't brought the machine to dig a trench. He brought it for the 1% of situations where modern efficiency fails, where speed is actively a detriment, and where all that matters is a machine's sheer, uncompromising refusal to let the earth win. The old iron didn't work because it was magical. It worked because it was built for a singular, brutal purpose that modern engineering had engineered right out of its own equipment in the name of comfort and speed. Arthur Vance has long since passed, but that massive iron machine has not frozen in time or gone to the scrapyard. Today, it sits quietly in a well-maintained steel shed on the Vance family property. Every spring, his grandson walks out to the shed, starts the pony motor, engages the main diesel, and drives the crawler out into the sun, keeping the fluids moving and the heavy iron alive. The most reliable advantage a man can carry into a crisis is not a $500,000 price tag, and it is rarely the absolute newest technology. It is a quiet, calloused understanding of the exact mechanics of the problem in front of him. The world is full of modern solutions that rely on speed and high pressure, just waiting to be humbled by a guy who simply knows how to grip the earth.